So today we will be seeing the problem generate all valid parentheses. So what this problem states is that we will be given an integer n. That integer n can be anything and any positive integer. Let's say we are given with an integer 2. What this question expects is to generate all the valid parentheses. So if let's say we are given with n is equals to 2, then what all valid parentheses can it generate? It can be first this and this, second this and this, third. A question to you all: can this be a valid parenthesis? Similarly, can this be a valid parenthesis? Of course not. Of course not, because if I say valid, then that clearly means is that number of open should always be equal to number of close. So that comes with it. Whenever I say all valid parentheses. Okay. So I think this part is clear. Now let us just deep dive into the pseudo logic that we will be writing for our code. So I'll just change the color. So this part will be focusing on the pseudo logic. Okay, just bear with me. I'll just be hard coding some things, but why those hard codings are being done, that will be explained, but in future matlab in 2-3 minutes you will get the point why am I doing this hard coding. So yeah, let us first anyways we need to return number of or array with some strings. That strings is our combination or permutations of all the types of parentheses that we can generate. So anyways we will be having our temporary array. Let us name it as temp. We will be keeping a variable. Let's say the variable name is str, and that will be empty in the very starting, because we will in future be appending some close and some open braces to it. So let's not go into that part right now, but okay, let us start writing our helper function. So this is our helper function. What it takes, anyways the n part will always be there, so integer n, it will always be there. Temporary array will always be there. Our str will always be there. Why it will always be there? Because we will be modulating this only. In every instance of recursion, we will be modulating this part only. Okay, so you will see why am I referring to the word modulating here, but yeah, we will be modulating this string only. And then just remember this, we will be requiring the number of open braces. So let's name that variable as open. We will be requiring the number of close braces, so let's name it as close. Okay, this part sorted. Now for the base case, I'll just be writing it in the very last, but let us first think of the recursive call that we will be doing. I'll just write it, then I'll explain it. Okay, so this will be our recursive call, helper. First recursive call, helper function. I'll explain it. Just be patient. N, temporary array. I told you that we will be modulating this. So string plus something. What is that something? Open bracket. Why only an open bracket at the very end? Why not call a recursion with the close bracket? I'll be explaining that part. Okay. So we have a question here, why a open bracket? Whenever we add an open bracket, we will straight away be appending this. So we will straight away be incrementing this open variable. So open plus 1. and close remains as it is. So we received a question here. Just mark it as Q. Okay. That Q was Y open bracket first. Most of you will guess why this question arised, and you will guess the answer also. But let me just write the next recursive call, and that comes with a if condition. Why that if condition? That also I'll be explaining. If opens count is greater than closes count, then only helper function n temp str plus something. What that something is? That something is this. Why this? I'll be explaining it. Open remains as it is, close goes here. Because we have appended a close, so that is why we are incrementing the close variable. Question, very prominent. Why this if condition? Okay, so we have two very prominent questions, the question number 1, question number 2. Let us try answering those two, and then there is nothing much left here. Just close this thing. Base cases are left, yeah, that we can write anyways, but base cases and how our answer variable will look, that we can write anyways. But let us see the first question's answer. So think of a case, you know at the very instant, at the very start of the recursive call, the string variable will always be empty. Okay, the string variable will always be empty. There can be a recursive call. Let's say you were not having, let's say at an instant you were not having this if condition. You were straight away doing this. Then at an instant, let's say these two are recursive call. These two will always be a recursive call, and the string variable was empty. There was no open bracket appended to it. And the string variable directly came to this helper function, this recursive call, and it tried appending a open bracket. Is this even a valid case? No, not at all. It tried appending a close bracket, and it also tried incrementing the variable. That can never be a good case. That can never be a valid case. Why? Because you anyways know that in a valid parenthesis, you will always be having this now. This, then this, then this, then this. So at the very start, the thing I think we talked about, and I think if I made a mistake right here, this thing right here, this also is not a valid parenthesis. Why? Because you always are not only checking the number of opens and closed. You always are not only checking the number of open and closed. You are always checking that yes, the number of opens should be equal to number of closed, but very big thing, the number of, or what should I say, not only based on number, number is just the counting part that we are doing. The open brackets should always come first. come first before closing once. Okay, so this in turn becomes a wrong case. This is the only valid case. This is first, this is my mistake. N should not be 2. For 2 there can be more cases, but let us for now discard this as 2, and let's say this was 1. Then we need to generate a 2 into n number of parentheses, so this becomes the only parenthesis that is valid. Okay, now coming to this part right here, I think by answering this question I have solved this one right here and this also right here. Why? Because anyways if your opens are not greater than the close, if your opens are not greater than the close, let's say you are having a string, hypothetically string is something like this: open, close, close. Is this a valid string? First of all, no, but this can be generated now. Who told it cannot be generated? It can be generated, but herein if you see, the number of opens is equals to 1, the number of close is equals to 2. 2 is greater than 1, that is close is greater than open. And if that is the case, then and if you don't do this check, then you will again be appending a close, you are making this more bad, more not valid. So you were having a bad string, you made it more worse, so that cannot be a good case now. So we need a check here that open should always be greater than close. So this is a valid case now. Let's say you have this and this, and now what you are trying to close it. Then yeah, at a certain stage it can become valid, so yeah, this becomes a valid string. This case also right here, you did like this something: 1, the number of opens are still greater than the number of close, and you are again coming into this recursive call and you are trying to close. Fine, it will be a valid thing, not an issue. So this check right here is important, we cannot neglect this check. So just erase this and right here, no more neglecting this part. Both of these questions are solved. I'll just do a tick mark right here that these two are solved, and this is also solved. Now the only thing that is left is for us to understand the base case. What can be the base case? So we know now at every moment we are appending a close or a open bracket to this string variable. Okay, so and the very first thing that we were told, if you are given an n, you will always be generating 2 into n, not equal, but yeah, 2 into n number of parentheses out of this. Correct? You are given with n, you will be generating 2 into n number of parentheses. Let us say while appending these parentheses right here, you were appending this, you were again appending this. Let's say your n was 2. So what do we mean by this 2? Half of it should be open, rest half should be closed. This is clear now, this is clear to us. But what we saw is the string that we are generating right now. This is the string that we are generating right now. Obviously the count of open is 3, and we were told if n is 2, the length of our the final string that we will be making will have a length of 4. 2 into n now. So 2 into 2 becomes 4. So for a 4 length string, 3 of them are open. If I try appending one more clause, will this ever become a valid string? Obviously not. Obviously not. You have exhausted the length of the array. You have exhausted the length of the array. And after exhausting the length of the array, you cannot go ahead now. This can never be valid. You cannot, first and foremost, you cannot extend the length here. You cannot add two more and say ki this becomes valid. No, you cannot say. After exhausting the length, you cannot append more. So first and foremost base case that we see right here, and that is the only base case that we will be seeing, is if at any moment the count of open becomes greater than n, that is the half. N is the half now. We require to generate 2 into n number of parentheses, so n becomes half. At any instant it increases n, return. Not a valid case. Not a valid case. Second and most important thing, when at what instant you will be adding this str to your final answer array. This array we need to append it with strs now. So the check that we always remember, if the addition of open plus addition of close, the count, these two count, these and this right here, is equals to n, is equals to 2n. Okay, and first and foremost this should be equal to 2n, and second of most important thing, half should be divided, half and half should be divided. So open should be equal to close, the count should be equal, their sum should be equal to 2n, and half open should be equal to the count of close, count of open equal to count of close. That is it. If that is the case, then buddy just erase this. Well, buddy will not erase, but yeah, just to keep this part right here clear, what we will be doing, if that is fine, then append it temp dot push back or whatever, matlab depends upon which language you are using. So just erase this all, dot push back or append. In general words, let's say append the str as of now, just do this. That is it. After doing this, what you need to do extra, just return it. That is it. You are done. This is the base case. This can also be a base case. This can also be a base case. Yes, this is also a base case. So two of our most prominent base cases are written. Recursive call is done. Two questions were answered. The logic is clear, and let us talk a bit about the time complexity thing. So let us see what can be the time complexity. Okay. So time complexity. So we all know na, let's say for n we required to generate 2 into n number of parentheses. So let's say these all places were supposed to be filled. So this was having a equal possibility, matlab, of how many integers we could have filled it in here was let's say not 2, open or closed, this also open or closed, this also open or closed, and this also open and closed. So that incurs a time complexity of number of places now. So 2 to the power uh, 2 to the power 2n. Correct. Getting now why 2n? This is not n. This is not n. This is 2n places. This is not n. This is 2n because we were given with n. The number of places are 2n. 2 to the power 2n. Got my point? So this can be the time complexity and the space complexity. Space complexity, just SC. At the very worst case, we will be using 2n spaces to fill up this, this and this. So the space complexity can be at the very worst 2 into n. Okay, so time complexity is 2 to the power 2n because these all gets multiplied and this is just the space that we will be using. And yeah, I think that is pretty much it. And if you just see the code part, the code also is similar. So no magic in here that we did not talked about up till now. We can just have a look if you want. This is the base case that we were seeing from the very start. This is also the base case that we were seeing, and we appended it into the array. We did a return. There was this general recursive call that was appending an open bracket. Then we were talking about this condition. Why are we having this condition, and why are we having this close with a condition? We talked about it, and at the very end we will be returning the array. That is it. No extra stuff in the code, at least. So yeah, that is it for the video. Thanks for watching. See you again.